Hello, everybody, and welcome back to the channel. So today we're going to discuss about how we can scale LLM-based systems. And so we're going to deep dive into one of the most exciting features for me personally in Databricks, which is the serverless batch, which what it does, it really simplifies how we can run large-scale LLM inference jobs. And so today, to go through this topic, we have with us Ankit, who is the tech lead on the serverless batch side and the staff engineer in Databricks. So let's start by introducing Ankit. So can you tell us a little bit more about yourself and your role?
Yeah, I'm excited to chat with you guys. So a little bit about me. I have been at Databricks for 6 years, working kind of broadly in the AI machine learning infrastructure area. Before that, actually was working also in AI infrastructure as a researcher in Matei's lab.
Nice.
And before that, went to Berkeley. So kind of have just bounced around the Bay Area for a bit, but have loved it here. So excited to chat about this new thing that we've built, which I think is the most exciting new kind of project that we've been working on.
Awesome. And so how did you get involved with Databricks in the field of machine learning infrastructure in particular?
Yeah, I think that goes all the way back to Berkeley because I don't know, like when I started first couple of years, I just generally liked writing code and doing tech stuff. And after that, I got a little bit excited about systems work. And so I thought I would do some research with systems researchers. And so in my senior year, I was able to get a research kind of helping position in Jan's lab, Jan Stoika. And so was working there on some reinforcement learning stuff for like the Spark planner. And so that was just fun for me because I was just learning about systems, getting involved with research. And I thought at that time I wanted to do even more research. And so that's how Jan connected with me with Matei. And then for obvious reasons, right, like with Matei, he was like, hey, you should intern here at Databricks. And then when I interned here, loved it. It was a really small team. There was like Aaron Davidson, Manny, and a couple other people. And I had such a great time that I ended up just saying, I don't want to do research anymore. And I came back here.
Oh, amazing. Thanks for sharing some intel into what is happening.
Yeah.
In terms of serverless batch now, you have written a blog with you as a tech lead and then a couple of other people around serverless batch. And can you explain a little bit what it is in kind of TLDR?
Sure, yeah. I think very simply what we wanted to do was give people a product that made it easy to apply the intelligence from LLMs on their data, where the key difference between applying it on data is that there's a ton of scale. And so you might have like terabytes of data, and then you immediately, as soon as you get to that scale, you start running into just the worst problems in the world. Actually saw this because we have the foundation model API product in Databricks generally, which is intended for real time. We designed this paper token and provision throughput products for real time use cases. And we just were looking at our customer base and they were just going through a bunch of pain trying to use those products for batch because you have to run a bunch of parallel requests, implement rate limiting, figure out how big your endpoint needs to be. And so it almost felt like people were just like, they had such a strong need for it. And that was exciting. But then they were having to bash their heads against the wall trying to get it done. So that's really the problem that we built the product to solve because we just it should be easy, right? And the great thing about the folks that we work with at Databricks is that they're all their data lives here in general. So then they all have this problem. And so the applicability of the product is actually even wider than I would say even the original LLM product that we had.
And so how does it differ from traditional batch inference on Databricks?
Yeah. So the big difference between these LLMs and maybe like, for example, a pandas UDF or something, right? Which is the way that you would have done batch inference with a classical AI model, is that the compute needs for the model are very extreme, right? So you want to run the models on the best hardware. You need to, in order to get that hardware, you need to like make 3-year reservations and go through a bunch of headache to like go pay for those GPUs, right? And so no one in their right mind who's just using this for batch inference for like a day is going to go through all that infrastructure hassle.
It's pain. Yes.
Yeah. And so you can't, for example, launch a cluster as a result with it because getting those GPUs in your account or even in someone else's account is very hard. So then there's a ton of economies of scale that come from buying those GPUs all for a bunch of different use cases and then being able to share them. So now you get into this model where even though you're starting the job like traditional batch inference job would on Databricks, you're actually reaching out to this other service. And that's a different architectural paradigm. And so that's what we've really kind of tackled in this latest launch of the product.
Cool. So can we deep dive a little bit then on this? So what's happening behind the scenes when you schedule a job in terms of handling scaling, cold starts, and how do you do dependency management?
Yeah. So what happens, so like I said, right, like we have a bunch of different folks who use the service. And so actually I'd like to start by saying what the objective function that we have for the product is, which is that we actually want it to be predictable. Right? Because we found that people who use these things in their ETL pipelines and things like that, they have like SLAs for those pipelines. There are business reasons that they care about those. So we want this service to be predictable. We don't want it to like take 1 hour one day and 10 hours the next day.
Okay, when it's predictable in terms of how long it's gonna run for.
Correct. Yes. The second thing is we want you to be able to use it immediately, right? And that's actually in strong contrast to other batch inference products in the market, where we actually are able to start your job as soon as you run it, which means that it can finish in, maybe if you have a ton of data, like an hour instead of, any time in the next 24 hours, which is what a lot of other batch products do. And then finally, we want to be able to run tons and tons of data through this at very high scale, like really quickly. So we don't want this to be like a slow drip where it takes like 10 hours or 10 days to complete. The issue is that those three concerns all compete with each other. Like you can really easily offer a very predictable product by saying, well, I'll just give you like the smallest amount of compute, and then your job will just be super slow, but very predictably slow. It's like predictably bad, right? So then we actually ended up having to build this scheduler that looks across all of our jobs and all of our capacity. And it basically operates with this objective function where it says, well, I want to let people start jobs. So if we're at capacity, we'll find a way to start your job by fairly kind of removing capacity from other jobs. It also says, well, I want all the jobs to run at high throughput. So then it'll try to scale things up. And then finally, it looks at historical trends to understand how much capacity do I expect to have? And it tries to manage expectations by only scaling you up to a capacity that we confidently think we might have the next day. And so then coming back to your original question, what happens when you start a job? All of that complexity is abstracted away from you. What happens is you create a session with our scheduler who then becomes aware of your job. And the scheduler will allocate you some capacity within our service. Then you actually, our client will start sending requests to the backend, which will, respect that rate limit. And then the scheduler is kind of always watching and paying attention to all the jobs. And so if it sees like a job is like rate limited, for example, at a high rate, it'll say, well, okay, like clearly this person has a lot of data because they've been around for 5 minutes and they're getting rate limited. So let me give some more capacity. And so it will do all of that behind the scenes. All you've really done is click run on your job. And it'll scale up and down based on the global needs.
So all that complexity is abstracted away from you. You just click run. Is that what you just said?
Right. Yeah. And actually what makes me really excited about the interface for that, right, is like once you start with those constraints as a product, then you realize, well, okay, well, if I have this, this system backing it, I can actually write this in terms of SQL. And so all you actually really do is start your SQL job. Or even more abstractly, if this is just one task in your pipeline, your pipeline is running on a scheduled basis. So you may not be doing anything actually, but it just gets triggered.
Awesome. And so what are the limits in terms of model size, data volume, or runtime? Can you tell us a bit about this?
Yeah. So because it's a service that we run, you don't have to think about like, well, can I get a cluster that's big enough for this model? That's actually our job, right? And so we end up scaling up these models on a lot of compute in the back end. And so there's not really, I would say, a limitation on model size. There are a set of models that we think are better for batch inference than others because, there's kind of this intelligence versus cost trade-off. And we like to guide our customers to the right place in that story because at the extreme higher ends, you can pay a lot of money for very little intelligence. And at batch scale,
bigger models, right? In terms of
right, yeah, like 405B, for example, Llama 405B, right? Like you can scale that up a lot, but there's diminishing returns relative to 70B, and so at batch scale, those diminishing returns amplify, and your job is like way more expensive than otherwise. So there's no limitation on model size. And then on data volume, like I said, right, like because the product will scale up and down, we can handle lots and lots of rows, millions, tens of millions, hundreds of millions of rows people have run through our system, actually billions as well. So I wouldn't say there's a data volume limitation. Obviously, there's constraints on how long it'll take to get done, right? So it's really more about the combination of model size, data volume, and your expectation for how long you need the job done. That's where you might, You can't get like the biggest model on petabytes of data in 1 second, but you can get it done at some point.
Amazing. And I think a question now that we probably should have started with is, what are some of the real world scenarios that some like customers have used this solution for? Maybe
Yeah,
we should
I mean, for sure. I mean, honestly, this is what excited me about joining Databricks way back. Like, it was really just like, I like to see all these different things people do with the product because we're kind of bringing intelligence to a really impactful set of people. I would say that I've seen all sorts of different use cases. I've seen healthcare companies analyze like trial documents. I've seen insurance companies analyze contracts. There's just generally like learning from people's different PDFs within their organization. I think there's all sorts of unstructured text that people are trying to get entity extraction from. And actually some of those learnings, we took that and put that into agent bricks because those are the things we found people were doing really often, like information extraction, metadata extraction, and kind of those kinds of things.
And also to say here, we mentioned about AI query, but there are so many other AI functions, right, that follow the same pattern, like AI sentiment, AI mask, There are like a list of so many other functions that are scaled in the same way, if I'm not mistaken.
Yep. Actually, there was I guess I shouldn't name the company, but there's a very exciting thing about these functions, right? Because they're written in SQL, there's a hugely expanded set of users who can use them. So for example, there are financial analysts at certain companies that are using this to read various contracts that they have within their company, as well as externally. There are data engineers who are looking at this data, who use, like, for example, sentiment analysis or masking to to make sure that they're redacting the right content from things that they're putting in dashboards. So they're pretty widely applicable.
Awesome. So can you show us a little demo just so that we see how people can play with it?
Yeah, of course. Let's do it. So let me just set the context a little bit for this demo, right? Basically, one of the things that what I did here is, like, let's pretend we are running a shoe store, which I called Lake House Laces. And we have a bunch of shoes, we have a bunch of review data, right? That's a super common use case for someone who's running a consumer-facing sales application. And so I have that stuff in this table, in my Delta table here. And you can see all sorts of the regular stuff you would have. You have like product ID, when the review came in, the headline, the body, and then a bunch of other stuff. So normally, right, let's say you wanted to actually learn about this data, you might actually need to train a model specifically for review analysis, which is a lot of work. And without that, you might not, I mean, you have thousands or millions of these reviews. There's no way you can extract learnings from that, right? Me, myself, I downloaded that. I got this data set like literally less than a day and a half ago, right? So I actually don't even know. I'm trying to even get my bearings in this data set. So you can obviously use SQL for that. It's a very natural tool. And you can look at some of the data sets, but let's pretend that I actually am like kind of on a deadline. I know I have one product ID that we just launched, and I want to make sure that it's actually like, I understand exactly how it's going. And so let's say that's this product ID here, and that's some kind of a shoe. So what's interesting here is, if you look at the data, right, like any data, anyone who has worked with data knows that the hardest problem is the quality of the data. So you see a bunch of good reviews, and then you see this like kind of random review about like a phone charger, and obviously that's not useful, right? So if I built analysis on top of this data set without extracting that out, I'd actually be causing a huge problem, right? Because I'm building on top of bad data. What these models are really powerful for is that they're actually these general purpose intelligence machines. And so with this SQL-based interface that we're offering, we actually are bringing that to your workflow, right? So this is a cool thing that we started doing and taking a look at, which is, what if we, like, rather than going and building our own relevance model for shoe reviews, we actually just asked this model to be like, hey, I'm going to show you a review for a shoe or a boot. Does it even sound like that? And if not, then we can just exclude it, right? So you all of a sudden have brought this intelligence to this where clause that otherwise it would have been really, really hard for you to do. And so, okay, cool. You're able to just filter out for the relevant models. And now here's like kind of another thing that you can do, right? We were talking about the functions generally. It's literally 2 more lines to now say, well, now that I have that, summarize the review for me, and tell me whether it's a positive or a negative review. Again, this is really showing off the power of these models, because I literally would have had to, even like when I was in grad school, would have had to train another model for each of these tasks. And so now all of a sudden I have this really awesome summarization, I have sentiment, I have a lot more understanding of what's going on with this shoe. And I mean, one of the powerful things about this product relative to other products is that we don't ask you to like take your data out of the Unity catalog or out of your catalog at all, right? Like as a lot of other products will say, well, dump this into a file, then upload that file somewhere, right? And in that process, you've already broken a bunch of rules within your organization. This is going to respect all the same access controls and governance that are in Unity catalog already. So if I don't have access, let's pretend, to a certain set of data, it won't run on my SQL query. And then the other cool thing about the product is I can do like exploratory data analysis like this with a small amount of data. Going to production is just as simple as removing this limit statement, right? And then I run it and it starts, the system will scale up to as big of a scale as I want. So we do a couple more things here, right? Like let's say we even make the task more complicated. One of the features that we offer in this product is this ability to get responses back in JSON format. That's a really powerful feature because A, it allows you to really constrain the model's outputs to exactly the task and structure that you want. And B, it creates an output that's actually usable by, for example, applications that might be downstream, right? That are able to then process that JSON as an API request. Like let's say you had an app or something, right? Like it might be cool to have a little UI thing that shows you like what's like the most mentioned key product feature of this shoe. Because this is extracted as JSON, I can actually do that. And so you can see here, all you do is you write in the schema here, and it comes out like this, which is really cool. And so there's a couple of more things like this that we did. Then what we were able to do is actually put together this dashboard. So this dashboard has a lot of depth. I mean, it is like you have this product ID. You could have done this for any product ID for what it's worth. You know how many reviews you got. You know how many of them are positive, negative, mixed, average star rating. What's cool is that you can actually also summarize, get this like general purpose summary of what's going on with this shoe. And so this is a little bit more like if you were looking at like an executive level summary dashboard, then you just have the ability to do that without having to bring in someone into the loop. But then, I mean, you may have noticed that thing about the features, right? This offers you the ability to really understand what are people talking about with this shoe. Are they complaining about, it seems like it's like a little tough to break into the shoe, but then like a lot of the reviews are pretty comfortable after that. Sizing seems to be an issue, but quality and style don't seem to be a problem. And then you can, if you wanted to deep dive into this, right? Because of the AIBI dashboards, right? Like you can literally just click on, let's show me the positive comfort reviews. Let me just make sure, right? And they're all here, right? Or show me the issues with break-in, right? And then you can actually see what's going on over here. And so the reason I'm emphasizing the ability to integrate these functions with the dashboards is that it's only possible because the interface is SQL oriented. And actually that's the product vision that we started with. We started with, well, how do I bring this into the other surfaces of Databricks? That results in, well, I need a SQL interface, and that results in these infrastructure requirements that we talked about. Right. So that I think is very, very, very cool. And just one last thing here is we actually set this up so that it's incremental using DLT or LakeFlow pipelines. And so every time new reviews are coming in, you literally don't need to do anything. It automatically will trigger all of the AI query stuff or the AI functions, update the dashboard. So that's a little bit of a demo around how it works. I could run it. It would run pretty fast, but I just wanted to show a little bit of our vision for why it's useful in this way.
I love this feature. It's very slick. It's so easy to implement. It's like beauty.
I love that it's so easy to do it with SQL. And so it's really any data analyst can run it. And at the same time, we talked about all the scalability that it offers under the hood and that Databricks has customers that have run this on millions of rows. And respecting also your governance model. That's really powerful.
Now that you're saying governance model and security maybe. So how is security handled when you are using the product?
Yeah. So like our foundational model API product, we totally built with security in mind. We have a security perimeter, and so this is running on our hosted models at high scale. So everything kind of stays within our security perimeter when we run the inference. It's all serverless, so there's no like worries about connecting via key management to your resources. Like we manage all the resources behind the scenes. So it's all, and then as I said, because it's SQL oriented, respects all the row-based, table-based ACLs that you might have.
And what kind of cost savings optimizations can people expect?
Yeah, I mean, I don't like to give people a number because it's very dependent on what your use case is. We've found that because of the ability to use this, just forgetting about the cost savings from workflow management, right? Like, and having a simple workflow, even just running batch inference relative to other, models out there, we often find ourselves, more than 50% cheaper, especially for specific kinds of use cases. So definitely recommend people try it out and give us feedback on the cost, but we expect to come out quite a bit ahead on that.
Amazing. And then we discussed a little bit on the models and which models make sense for this kind of workload. So we said kind of very big in terms of parameter models we don't support. But like, what are the models people should use with this kind of product? And are we planning to support more? What is the status there?
Yeah, no. So I would not say that we don't support it. I think that like for 4 or 5B, we don't encourage it, but I think there's two sets of use cases, right? The smaller models like 8B, 70B that we think are really, really good for like workhorse use cases where you have a lot of data. But I also think for use cases that are extremely quality sensitive, it's also useful to reach out to these models like Claude or Gemini. And so we are releasing closer to the end of the month is the ability to use those models as hosted within our AI functions. And so this is something we see a lot of demand for because people do worry, like, especially if they're doing something business critical, that the quality needs to be high. So that's top of mind for us is improving that story. And one way to improve that story is by giving people the ability to use this with those models. Now there actually draws an even starker contrast because, obviously like Claude has its own batch upload API. We've actually found that a lot of people really find it convenient to use the iQuery and the SQL-oriented interface for this. So that's what we're going to offer. Eventually we might offer something that's more cost optimized even for more, but that's what we expect to release.
And what advice would you give to ML teams that are looking to adopt this today?
Yeah, I guess the advice I would give is
just try it.
Yeah, I mean, obviously, just try it. Like, it's really easy to try. You can use it with small amounts of data if you're worried about, like, cost or something like that. But you have to kind of, it's like one of those things where you try it on and then you realize, like, oh, I love it. And so you have to give it a bit of a try. The other thing I would say is that, at least for me, I think it changed the paradigm of how I think about analyzing data that I don't understand. And so I think it will really, everyone needs to embrace this as they, write code or do data analysis or whatever it is, that like these models are going to change the timelines for things that you think that you were used to as being very long maybe becomes really short. So you have to actually rethink your workflow. And in order to do that, you have to actually try it out. So definitely recommend people do that.
Amazing. And then you can also use it on the SQL editor. You can use it through notebooks. You can use it with PySpark.
Yeah.
So
and if there's a place that you can't use it from, just let me know.
Good. Sounds good. Thank you, Ankit.
Awesome. Yeah. Well, thank you for giving me the opportunity.